Hello and welcome to another video from Ellensburg Amplifier Repair and Service. Today we have a Taramps MD 8K, the 2-ohm version, on the bench for repair. So this 8K has the typical blown output section where the drain has blown the traces apart on the board, which is common. I see this all the time, and it's particularly on this bank. So for some reason, I get more failures on the, how would you look at this, from the speaker terminal end, the left-hand side. I get more failures on this side than I ever do on this side. So something about the design itself tends to present having more current drawn through one side than the other. And that's just how I'm seeing this, with all these traces being blown open here and no damage over here, and it's always this side. So I'm not sure, but it looks like someone may have already gone through and cut the gate and source legs of these transistors, or this is just heavy vibration damage. I'm not sure, but it is here for repair, so we will go ahead and fix this up. So I'm going to do preliminary checks of the power supply. Most times on the 8 and 12Ks, when you have the failure of the output section, the power supply is typically okay. So we're at 5K. 5K there, and we are 5K there. Gate and source. 5K and 5K. And why do I check twice? Because you have two sides of the transformer here. You're going to have a drive on one side and you're going to have a separate drive on the other side. I'm just verifying that the drive itself is not shorted to ground, or we don't have any shorted power supply transistors. Again, typically does not happen when they burn up on the output like this. I know for a fact this side has to be rebuilt. So it'll be the IRF B4 4127s for the power, or for the transistors, and you're gonna have to replace the 15-volt Zener diodes down here. Sometimes the damage does make it up to the gate and goes over and damages the SI8244 IC. Very expensive ICs to get currently still. But I'm going to check this side here. Usually there's no shorts on this side. 8.5, perfect. And 10, perfect. You'll see the like 8.5 or 8.5K, and then you'll see the other side go up to about 10.5K for a good drive. So it takes just a second for me to verify that we do not have any problems on this side. Sorry, I don't have my scope image up here for you guys because the USB port is plugged into the camera up top here. So I do excuse not having that meter up there. Also, just to let you guys know, I do have my affiliate links back down below for Amazon. If you ever question the materials I use, some of the equipment that I use, you will find links down below of the stuff that I do use on a regular basis. There might be some items down there that I use every now and then, but most items that I list are items that I use on a regular basis. One of the newest members of my arsenal here is the BW, whoa, backwards upside down here, BW100 contact cleaner. This stuff is just fantastic at potentiometers, clean potentiometers, and switches. So just let you guys know, backwards, this BW100 you will find down below. So this really is a straightforward repair, typical as we normally do on any of the 8 and 12K amplifiers. And we're going to take a peek at the bottom side, because sometimes you do have traces that pop open on the bottom. And if we look right here, we sure do have a trace that is opened up on us. So we just have a bottom side trace repair to do. And of course, removal of the transistors for that side. So excuse me guys, I'm going to flip this board around here. So as I can work on the output section. Looks like my brightness might be a little low here, so let me brighten this up just a little bit here for you guys. If I use the right setting on the camera, I'm not sure. Again, as I have always said in the past, I am not a camera person. I don't know the first thing to cameras at all, whatsoever. Let's see here. I'm going to scrape back some of the solder mask of this trace here. Sorry, it's going to sound like fingernails down a chalkboard. I have another new toy on the way that some of my viewers may recognize when I get it out on video for you, but I do have a new tool coming that you can find another YouTuber offers. So I will do my own little independent review of it. We will thank Alex for that. So I'm just going to use my hack on my FR301 here. It does have a little bit more thermal mass, a little bit more heat to go ahead and apply solder to the trace. That did suffer a little bit of damage there. I'm going to go ahead and remove the transistors that are currently the board, and I'm going to attempt to remove the pieces of transistor leg that somebody so politely decided to cut off right at the board. So it does make it a little trickier to get these out of here. What I'll do is I'll heat up the pin, reach up in there with my tweezers, and slide that pin right out of there. Usually when I'm diagnosing amplifiers, I'll cut the transistor legs, but I'll cut them in a way that allows me to have some transistor leg available to grab with the tweezers. So just a little tip for you guys that do repair amplifiers. Just, I wouldn't, don't cut your transistor legs off right at the board. It'll save you some hassle. Because it is a hassle when you can't grab these things. See, they cut those transistor legs right up at the board. That's okay, we can manage, we'll make it. Just another typical 8K repair here. Now don't get me wrong, these Taramps amplifiers are not bad amplifiers. They could use just a little bit of work here and there on certain areas of the board, and most times when I hear of someone getting an 8K or 12K, it's particularly the 8 and 12K amplifiers, that I let them know that hey, you may want to think about sending it in to have a little bit of work done before you run these things, competition full tilt style. Because there are some things that I do that will help prolong the lifespan of your amplifier. So this customer here, his name is Juan. He does have 2 amplifiers here, but has requested, you know, videos to be made. So I try to accommodate customers the best I can when it comes to the repair process or what I have done with their amplifiers. That's the reason why I do release, you know, videos the best I can. Sometimes I do run out a little bit of time to get everything set up and start recording videos, because everyone needs to realize that it does take time to get this equipment running. So since we're working on the bottom, I'm going to go ahead and repair the trace here that has blown apart. And what I do is I use, it's copper tape. Really fantastic stuff. It's about the same thickness as the trace of the board is. You can get this, of course, off of Mauser. But what I do is I just use my scissors here and cut off a little piece of copper. And then I kind of form it to fit my work. So I'll use my scissors to form the copper in a way that suits the board. Because then I will show you again what I do. There we are. So there's the copper on the trace itself there. Let's see, can I zoom you guys in? Maybe get you a little closer on this. I'm not sure what that's going to do with the picture quality here. Let's see here. There we are. We'll get you zoomed right in here. Some of the nastiest quality of picture there. Let me, can we change cameras here? We'll just change cameras up. There it is. All right. So there's our copper there. As you can see, I've formed the end of it just to kind of fit over this via for the transistor, but I'm a little too close right here. So I'm going to narrow that up just a little bit more. As you can see, I'm covering up the whole via. Don't worry, I'm doing that intentionally. All right, and then what I'm going to do is I'm going to just kind of draw a little line on the copper here, because I'm going to cut it right there. Fit it right over that spot. Looks like I might be a little too high up on my, what is that called? The exposure? Did I use the short screws for the cover? Yeah, but we're gonna hold off on the cover. I need to make sure I double check everything. There we go, that looks better. Sorry, we'll wait for this to shake and to settle down a little bit here. All right, so there's the copper. Of course, I've got the Echo, the FR301 all fired up here. Now there's a reason why I got a little solder prior to that, doing this on the trace itself. I'm going to put a little bit of Amtech flux. That flux will help this solder flow around and underneath that copper. So I'm going to get right down on there with the tip. I'm going to add a little bit of solder right to the top of that copper, just to help get that heat spread out. Right, so I solder that copper tape down to the board. Get rid of this copper tape. Does have a glue and an adhesive on the other end of it, but once you heat up that adhesive, it just kind of rolls off into a little ball. So I'm just removing the rest of the glue here the best I can, just so I can see to make sure that my copper is not too close to the via, to its neighboring via. Guys got to remember these things run at some pretty substantial voltages that can arc over pretty easily if copper gets too close to each other. I'm going to take a little bit of isopropyl alcohol here and clean up my area. And there it is. And as you can see, that copper is over the whole via. I'm going to take the tip of my tweezer and I'm going to pop a little hole right in that copper. Just like that. And then I'm going to take my Hacko one more time, and I'm just going to touch the end of that copper. There. And what that does is it solders the remaining part of that copper trace that I added right to the via. So when I slide the transistor through, it doesn't bend up my copper. And this is something that, again, I normally have to do on a lot of particularly the 8 and 12K amplifiers. I'm just going to flip it right back over here, and let's see what else we have to work with. So there's the other areas of trace that has been damaged. As you can see, it's pretty extensive, but normal. This is completely, in my opinion, I mean, it's pretty bad to say that it's normal. Let me just reference, because it shouldn't be normal. But the failure mode itself is normal. I really have not seen many of these fail, and really in any other way, short from vibration damage to the inductors, to broken these filter capacitors right here. I've had legs broke off at the board. So, and of course we've had, failed power supplies for some odd reasons why they fail. I don't know. I do get asked a lot why their power supplies fail, and sometimes I don't have answers for you. Why? I don't know your setup, so it's, again, really hard to answer those kind of questions. There are a few things on transistors that people need to know and understand. Like there's such thing as, I call it thermal runaway. I don't know if the technical term is like avalanche mode or what, but I call it thermal runaway, where a transistor heats up to a point where there's no stopping it from shorting. It just will continue to burn itself up until it shorts out in one way or another. Sorry again, this does sound like fingernails over a chalkboard, but I have to be able to clear off the area where I got to repair this trace right there. Of course you guys can't see because the inductor is right in the way. Now this tool that I got coming in the mail should really aid in this process. I do have a Dremel that I can run my dental bits over this, but it's a pretty big tool to get up in these little tight little areas. So hopefully on Juan's other amp here, this tool will be in and I can show you guys. The new tool. But as you can see, I'm just going around and just making me a new path here to solder down some copper, get that via back together. I just realized I'm missing a diode on this too. I have not had this board out yet. It's the first time this board has been out of the heatsink. I did diagnose it originally as being just just a typical output short. But somebody has been through this amplifier. I think. I mean, that's an assumption, but I would never cut a transistor off right at the board, so. And this trace right over here, you guys can just see it off the corner of your screen, that right at this 10 ohm resistor here, the snubber resistor, is a really tight spot when it comes to repairing the trace for this particular transistor. But not impossible. And this trace did get kind of hot. So I'm just going to apply a little Amtech flux to the exposed traces, and we'll get that Hacko, the FR301 down here, and apply some new solder. Hey, one transistor position did not burn up. How nice is that? We're going to add just a little bit of solder to that exposed copper. And it doesn't take much at all. That flux really helps flow that solder out. Ooh, am I going to have to remove that capacitor? Nah. Just like that. Then again, we just use copper. Copper. Let's fix this thing back up. This little itty bitty piece of copper right here is what we're going to start with. And I can kind of just gauge, just by looking at it, how I have to shape these. I've done so many that you just kind of get used to it. You start finding different methods. And remember, again, I cover the whole via. Oof, see how close we are to the edges of the gate and source? We don't really want to be that close. So what I'm going to do is I'm going to take my copper and I'm going to taper the end a little bit more. Without getting too small, because we want to be able to leave enough copper there to solder to the base, or the top, I should say, of that via that we left in place. Should be okay. Might be a little close still at the top. You know, sometimes you say it's like a fine art. There we go. Now we're looking better. Now remember, I had mentioned one side has an adhesive to it, so we're going to use the side that does not have the adhesive. We're going to use that side to solder down to the original trace. Then we use the FR, the 301 here, to heat up that piece of copper. Hold it right where I want it. No. There it goes. Just like that. I'm going to peel up some of this adhesive here real quick. Poke my hole. And then hold that soldering iron right at the end, which will solder the copper to the via. Although I went and soldered the hole that I punched in it, so I had to clear the hole out. All right, so there's one, and that's what we do. I'm going to do the same thing. I got 1, 2, 3, 4 more to do, and then the transistors for these for this output section will be ready to go back in. Actually, we're going to replace the Zeners first before I put transistors in, just to make sure that I have enough room to work around everything. So I will be right back with you guys. I'm just going to finish up these other traces real quick, and we'll continue on. Thank you. Be right back. All right, I've got all the new Zener diodes installed. These are 15-volt half-watt Zener diodes here. And I'm just going to install the IRP 4127 transistors in the output here. And you'll see that I bend the transistors in increments as I slide it through the via. It does set up the legs in a way to where it's lifted? No, because the board sits in a little valley, so the transistor's got to be the same height. The back of this transistor has to be the same height as the board, so You don't want to really bend them over flat, flush. That could cause a lot of stress to the transistor legs themselves, and I'll show you an example here of what I'm talking about here in just a second. And just make sure I get everything ready. So what I mean by bending them flush is, let me show you a transistor that I pulled off a board yesterday. You see how the leg itself is bent really square? So that right there is a point where it can break. And that's, I've seen a lot worse than that. Like here's another example of overbending the transistor legs. But the way I do it allows to have a slope to the leg itself to keep it from having vibration damage, well, to help prevent failure from vibration damage. So what I do is I just put them in the hole just to where the end of the leg is sticking past the board. I don't want them to fall out, but I'm going to flip it over so I can solder the backside. So excuse the camera view here for a second. All right, so there's the ones that I'm working on right there. And what I'll do is I will solder one leg first. And then I will hold the transistor in place, square to the board, and let it cool from there. This allows me to have a lot more control over where the transistor is soldered, how it's positioned. Because remember, I'm a firm believer in quality work. I just did a 12K. I think that was a 12K I have over on the other bench that I just finished up, and it was kind of a mess from the previous repair. I can see when somebody just doesn't put a lot of effort into the, I don't know how to, into the performance of their work, I should say. I have a lot of care in what I do. I want my work to be effective and efficient. So I have fewer returns. Which I don't get very many returns to begin with. Just probably for that reason, where I put a lot more effort into what I do. And not only in just the repair itself, but in the testing phase of amplifiers, the assembly. There's a lot involved in making sure that an amplifier will perform as expected. So I'm going to go through and I'm going to solder the top of all the traces that I repaired. And then hopefully this all works the way it should. but we're looking pretty decent. I like that. And that's how I get in there and repair those traces. Oh, hold on, guys. You see this one trace right here that I'm pointing to with the solder lead? That trace right there, that's the reason why I always recommend send the 8 and 12Ks in. Just add some solder to this trace right here, and I will almost bet that it'll take a lot more current to blow that open now. So there it is. That's the output section repaired. I will check the resistance values now to see if I have a bad driver. Again, this uses the SI8244 drive IC. It's a Class D drive IC. Perfect. 8.4. That's what I'm looking for. So we're looking for about 8.4, 8.5 to 10.5. And then on the other side, 10. There it is. So unless I have just bad drive signal, that's telling me that I don't have any shorts back in the bootstrap area of the circuit. There's no shorts, I should say, between the gate and source for the output of that IC. That doesn't mean, though, that it's not going to give us a good drive. So you'll know pretty quick if you have a high DC offset that the drive itself is not functioning the way it should. Which, to correct that, you just change the SI8244 drive IC. So for that is the repair of this amplifier. It's pretty straightforward. So just a general overview of the amplifier. It's still in really excellent condition. I should also, while I'm here, see, this is why sometimes shooting video does make a repair process longer, just to let you know. But we also got to go through and reinforce the traces on the other side so this doesn't come back for blown traces again. And it really is that quick, easy, and simple to help prevent failures. And the next thing about the 8 and 12Ks, of course, is loose inductors, capacitors. They will rock themselves right off the board. So I take my Gorilla Glue, my clear grip, and I just start gluing things down. It does not take a lot at all, because this stuff here, when it dries really solid, but yet you can still remove it. So that's why I use this. And I will also come down here across the inductor to secure up the inductor just a little bit more, because again, they are notorious for breaking off right at the board. And I also check the filter capacitors. There. So the maintenance end of the amplifier is done now. The glue is wet, so I'm not going to fire it up right now. This glue typically isn't conductive, but just in case, I don't want to risk damaging any work that I've already done. These do run at a pretty high voltage. These are running at what are they, 170, 160, 180, somewhere in there. They are 200 volt rail capacitors, so they've got to be about 180 volts, between 165 to 180 volts, depending on what version you have. So otherwise, this amplifier, it more than likely will start. I have no doubt in my mind it'll start. I don't know if the drive IC is still okay though. So that'll be the next thing to check once my glue dries up, so I can have a chance to fire it up. And then of course check the DC offset, which the DC offset is set by this potentiometer right over here in the bottom, kind of towards the bottom right hand corner there. This potentiometer here does adjust the DC offset between the two, let me scoot this over, between the two output terminals. So with no input signal here and the gain all the way counterclockwise, 0 gain, check your DC offset between these two terminals here with no load attached. I know, you're not supposed to connect things without a load, but as long as there's no signal in, you're on a test bench, that's where you can start this up and adjust your DC offset. Typically, you know, I can get them down to 0.008, 0.005, 0.002. It just depends on the tolerance of the circuit. And then other amps I can only get down to about 0.02. So it just depends on the tolerance of the circuit itself. So that's this 8K here, for the most part done. So I will let the glue dry. We'll fire this up, get the DC offset set, and put back together and get off back to the customer. All right, we are setting up and preparing to start this MD 8K for the first time. We're just gonna insert this into the video. Excuse me. See if I can get me some good connections here. Make sure my power supply is off so I don't inadvertently start it with and not be prepared for any form of unscheduled rapid disassembly of transistors. We have a good power supply. I got 12 volts going in right there. Excuse me. Let me see if I can get my meter to go on voltage here. So I'm just going to make sure I get a blue light, which I do. And I'm going to make sure I'm clear. Rectifiers are clear, clear, clear. Let's see if that drive IC still works. Once I get a good remote here. There we go. Here we go. Oh, we got a blue light. Blue is good. All right. So nothing came apart. Nothing blew up. Excuse me. I do have a fan that's sounding pretty bad. But what I'm going to do is I'm going to check the DC offset here. All right, so we're 0.04, 0.03 of a volt, 0.02. So we seem to be doing pretty good. Got a little bit of a noisy fan here. Sometimes these fans, the blade itself will vibrate the bushing right out. So sometimes you just got to push the fan back into place. Let me see if I can fire this back up. I did push that fan in a little bit more. So our DC offset is okay. I'm not worried about that. Yeah, these fans need a little bit of work, but Otherwise, I think this 8K is good to go. So we're going to get this thing all put back in the heatsink, back together, and we get it on the load bench and get it off to the customer. Alrighty guys, I just want to throw that in to show you guys how I fire this up. I just fired up, get little blue lights blinking over here, and get the rail voltage going. I'm making sure I don't have any rapid disassembly of transistors. So, right on, we'll move on with this video. Thanks guys. So I do thank you guys for watching. Please like and subscribe, like this content. If you have any questions, please leave them down below for me. Of course, I will respond to them as quick as I can for you guys. Love to answer questions and help out wherever I can. And as always, please keep your fingers safe of the rails on these, or any amplifier in the high voltage amplifiers. The rectifiers over here that you can find right here and over here will give you a very bad day if you get yourself crossed up in this while these capacitors are charged. They do have discharge resistors, but they are 6800. Oh wait, 2, 3. They are 68K resistors, so it does take a little while to bleed off the voltage and available current of these capacitors. So please be careful. If you don't know electricity or don't know about amplifier repair, don't work on these high voltage amplifiers. So again, thank you guys for watching. I'll catch you on the next one. Stay safe.